Newton's third law of motion. See, during the study of the interactions between the moving spheres, when Newton was establishing the laws of motions, he thought like this: when the interaction between two objects takes place, at that time one object exerts the force on other object. So is there any force exerted on the first object by that other one, or during this interaction only one force is acting or any other forces are in existence here? So when in this particular direction detailed studies were carried out by Newton, then after he suggested third law of motion, which suggests this thing: to every action there is always an equal and opposite reaction. The rule is very simple. Clear? To every action there is always an equal and opposite reaction. Actually, this action and reaction, that is nothing but the force. Okay? It means force. Okay? Now see here. No doubt, Newton's third law of motion, that is very simple thing. But some important points that we have to understand in this one. Right? Here when we say to every action there is always an equal and opposite reaction, it doesn't mean that the reaction that comes due to action, it is not like that. એટલે આનો મીનિંગ એવો નથી કે એક ઓબ્જેક્ટે બીજા ઉપર ફોર્સ લગાવ્યો એટલે બીજાએ પહેલા ઉપર લગાવ્યો, એવી કોઈ વાત નથી આમાં. ઇન્ટરેક્ટિવ ફોર્સ છે. એટલે જ્યારે બે ઓબ્જેક્ટ વચ્ચે ઇન્ટરેક્શન થાય એટલે બંને એકબીજા ઉપર ફોર્સ લગાવે. So actually this one is interactive force, means forces always are in pairs in the nature. During the interaction between two objects, two forces are there, both act simultaneously. One exerts the force and on another one, and that another one exerts the force on first one. Clear? Out of these two forces, any one can be treated as action, then rest will be treated as reaction. Now here, suppose we think about the force on A by B during the interaction between A and B. Then it is written as FAB vector. And if we think about the force on B by A, then that we can write vector FBA. But these two forces are equal in magnitude, opposite in direction. So we can write vector FAB, that is minus vector FBA. Now here, say, no doubt the forces are in pairs. Here we take two forces, one is action, another one is reaction, both act simultaneously. But one more important thing is this one: suppose after interaction you want to explain the motion of A, then you have to think about the force acting on A, not the force exerted by A. And after interaction, suppose you want to explain the motion of B, then you have to think about force on B, but not about the force exerted by B. Clear? So these are the important points related to Newton's third law of motion. Clear?